very good evening and welcome to Math Solutions by Aman Sodhi. In today's video, we are going to discuss Pythagoras Theorem, which is a very important chapter for ICSE, and we are going to discuss question number 11 to 15 for MLAggarwal ICSE Understanding Mathematics. So let's begin. In question number 11, we are given a triangle PQR where PD is perpendicular to QR. Also, we are given the sides PQ as A, PR as B and QD as C. DR is given as D. So we need to find the value of A plus B and A minus B, and we need it to be equal to C plus D into C minus D. So let's begin. In triangle PDR, let's apply the Pythagoras theorem. By Pythagoras theorem, PQ square will be equal to PD square plus QD whole square. Let's put the values. PQ square, which is equal to A square, will be equal to PD square plus C square. Let's bring C on the other side. We can write this as A square minus C square is equal to PD whole square, which can also be written as PD square is equal to A square minus C square. So let's put this equation as number 1. Similarly, if we apply the Pythagoras theorem to the other triangle, which is triangle PQD, then we get by Pythagoras theorem PR square is equal to PD square plus DR square. Putting the values, this gives us B square is equal to PD square plus D square, or we can also write PD square is equal to B square minus D square. So now clearly if we compare equation 1 with equation 2, we'll get A square minus C square is equal to B square minus D square, or we can interchange the values of C and B, which can be written as A square minus B square is equal to C square minus D square. And here we can apply the laws of algebraic identities, for which the solution is given here step by step. I hope all the answers are clear to you. Let's move on to question number 12 now. In question 12, we are given that ABC is an isosceles triangle and the sides AB and AC are given as 12 centimeters. The base BC is given as 8 centimeters. We need to find the length of the altitude on BC. That means we need to find the length of BD, and also we are supposed to find the area of this triangle. So let's begin. First of all, let's draw AD perpendicular to BC. Since perpendicular from the vertex to the base bisects the base, that means BD will be equal to DC. Now the length of total BC is given as 8 centimeters. So BD will be equal to DC, which will be equal to 4 centimeters each. This is also 4 and DC is also 4 centimeters. Now in right angle triangle ADB, let's apply Pythagoras theorem. Hypotenuse square, that means AB square will be equal to AD square plus BD square. Let's substitute the values. We can write this as AD square is equal to AB square minus BD square. Now since we already know the values of AB and BD, let's put those values. AB square here refers to 12 square and BD square refers to 4 square, which on solving will give us 144 minus 16. So let's substitute these values. We'll get AD square is equal to 128, or we can also write that AD is square root of 128, which can be written as 8 square root 2 centimeters. Now we need to find the area of the triangle also. So for finding area of triangle ABC, we know the formula is half multiplied by base multiplied by height. Applying this formula, we get 1 upon 2 multiplied by base, that means BC, which is 8, and altitude, which we have calculated just now, 8 square root 2. So the answer for this will be equal to, we can easily cancel 2 and 8 here. So 32 square root 2 centimeter square will be the area of triangle ABC. Let's see step-by-step solution for this question. This is the way you are going to present your answer in the examination also. Moving on to question 13, we are given a square in which we need to find the area and perimeter of the square. Also, the diagonal of the square is given as 10 centimeters. Now, since we know that in a square all the sides are equal, so let us suppose that AB and BC is equal to r centimeters each. Now, clearly, each angle in a square is 90 degree. So that means ABC is forming a right angle triangle. In triangle ABC, we need to apply the Pythagoras theorem. When we apply Pythagoras theorem, AC square will be equal to AB square plus BC square. Let's substitute the values. AC square can be written as r square plus r square. Since the value of AC is also given, that is 10 square can be written as equal to r square plus r square, or clearly we can write 100 is equal to 2r square. This gives us the value of r square as 50. That means each side of the square r is equal to square root of 50. Square root of 50 can also be written as 5 into square root 2 centimeters. So once we know the value of the side, we can easily find the area of the square. Area of the square is given by side multiplied by side. That means it will be 5 square root 2 multiplied by 5 square root 2, which gives us the answer as 25 multiplied by 2, or this is equal to 50 centimeter square. To find the perimeter, we know that the formula for perimeter of a square is 4 multiplied by side, which can be written as 4 multiplied by 5 square root 2, or this will be equal to 20 square root 2 centimeters. It is very important to write the units with the solution. Let's see step-by-step solution for the same. This is the way you are going to present your answer systematically with the units. Moving on to question 14a part now. In the figure ABCD is a quadrilateral. Values of AD, DC and BC are given to you. Also, we are given that two angles, angle ABD and angle BCD, are given as 90 degrees each. So using these values which are given, we need to find what is the length of AB. Let's begin the question. First of all, let's consider a right angle triangle BCD and let's apply Pythagoras theorem there. By Pythagoras theorem, clearly in this triangle, BD square is acting as the hypotenuse, which is equal to the sum of the squares of other two sides, CD square plus BC square. Let's substitute the values. BD square can be calculated as, value of CD is already given in the question, that is 12 centimeters. So this will be equal to 12 square plus 3 square. Or we can also write BD square is equal to 144 plus 9, which will give us the value 153. Similarly, in right angle triangle ABD, let's apply Pythagoras theorem again. AD square can be written as AB square plus BD square. Or we can also write AD, the value is given as 13 square, is equal to AB square plus 153. Let's solve this equation. AB square will be equal to 169 minus 153, which will give us the value as 16. So clearly AB will be equal to 4 centimeters. So let's see the step-by-step solution for this question now. I hope all the steps are clear to you. Moving on to question number 14b part. In the figure ABCD is a quadrilateral in which AB and AD are given as equal. So we need to find the value of AB and we also need to find the area of this triangle ABD. So let's begin the question. Let us suppose that AB and AD are equal, which is equal to x in this case. Since it is given in the question that AB and AD are equal, so we have supposed each of these sides as equal to x. Now, in the right angle triangle BCD, let us apply the Pythagoras theorem. In triangle BCD, BD square will be equal to CD square plus BC square. Or we can also write BD square is equal to, let's substitute the values. CD square means 6 square and BC square means 8 square. So BD square will be equal to 36 plus 64, which is equal to 100. This clearly gives the value of BD diagonal as 10 centimeters. Now moving on to the other triangle, that is right angle triangle BAD. Let's apply Pythagoras theorem in this case. BD square can be written as equal to AD square plus AB square. Let's substitute the values. BD square means 100 in this case, which is equal to x square plus x square. This on solving gives us 2x square is equal to 100, or we get the value of x square as 50, which gives us the value of x as 25 or 5 square root 2 centimeters. Now, since we know the side of the triangle and also the diagonal, we can find the area of the triangle also. For finding the area of the triangle, let's apply the formula. Area of triangle ABD will be equal to 1 upon 2 multiplied by base multiplied by altitude. This can be written as 1 upon 2 multiplied by 5 square root 2 multiplied by 5 square root 2, which on solving gives us the value as 25 centimeters square. Let's see step-by-step solution for this question. I hope all the steps are clear to you. Moving on to question 15a part. In this figure, AB is given as 12 centimeters, AC is given as 13, CE is given as 10 and DE is given as 6 centimeters. We need to find the length of the base BD. So clearly, in this case, we can divide the whole figure into two right-angled triangles. Let's solve this question. First of all, let us take right-angled triangle ABC. In this right-angled triangle, let us substitute the values by applying Pythagoras theorem. AC square will be equal to AB square plus BC square. Since we already know the values of AC and AB, let's put those values. 13 square will be equal to 12 square plus BC square, or we can write BC square is equal to 13 square, that means 169 minus 144, which is equal to 25. So this gives us the value of BC as 5 centimeters. Similarly, moving on to the other right angle triangle CDE. When we apply Pythagoras theorem for this, we can write CE whole square is equal to CD square plus DE square. Let's put the values. CD square can be written as CE square. CE square here means 10 square minus DE square, which is 6 square. Or it can be written as 100 minus 36, which gives us the value as 64. So from this, the value of CD will be equal to 8 centimeters. Now since we know the values of BC, that is 5 centimeters, and we know the value of CD, that is 8 centimeters. So total length of BD will be equal to 5 plus 8, which gives us the answer as 13 centimeters. So I hope the steps are clear to you. Let's see the solution for this now. This gives a presentation or representation of how you should present your answer in the examination. I hope all these questions are clear to you. In the next video, we will discuss the remaining questions of this exercise. Till then, keep watching. Thank you.